Following on from the previous video, we got to this stage here where D represents our time. So it starts at 0 and then it scans all the way to 8 pi. And C is the angle in here. And we've worked out L, the length of the string, and we've also drawn a circle of radius L, and the particle just keeps on spinning round and round like this. We now need to get it to swing back and forth. Okay, so currently in the previous video we got to this stage here where the circle just spins around in circles. We now need to get it to swing back and forth. To get it to swing back and forth, we need to look at the angle C. So even though we work in radians, let's just imagine C to be 37 degrees. Let's just imagine. So now we need to get it to swing between 37 and negative 37. So it's just going to swing back and forth like this. And then later on, we've got to incorporate that the time it takes to do one swing is given by this, by the length of the string and gravity on Earth. So the next task is to get it to swing back and forth. So we need to look at the angle here. We need to get it to swing from C to negative C. So we need to get it to swing like this. So now we need to, in a way, create a machine where we input D, the time, and then it will work out the angle for us. It will work out the angle for us. So this is what we're going to do. Because we want the particle to swing between C and negative C. Well, anything that's oscillating, to simulate something that's oscillating, you should think about the sine graph or the cos graph. Let's use a sine graph. So this is C here, and down here is negative C. So that's just like us imagining it as let's just imagine C to be 37, and so this here is like 37, and this here is like minus 37. So as time or D moves on, you can see 37 minus 37, positive 37 minus. So by using the sine graph, we are really simulating the positive 37, negative 37, positive 37, negative 37. So we're going to use sine to simulate this oscillation between C and negative C. Okay, so hang on. So this has to be C, from C to negative C. But the thing is, we want one swing like this to take this much time. So this length here, the period must be 2 pi root L over 10, because we're on Earth. We're going to say gravity is 10. So this length here must be this thing here. So now how do we come up with a formula for this? If I were to give you this, hang on, let's say we've done this in the past a long time ago. Let's just say I want an amplitude of 3 and the period of, let's say, 7. How would you come up with the formula for this? Well, it would be f of x equals, well, it would be something sine, and then with the amplitude would be 3. And then if you want what you do here to decide this bit here, you get this whole length here, which normally is 2 pi, and then you cut up into 7 equal pieces. You cut it up into 7 equal pieces. So in our case, to get this length here, in this case here, it would be 2 pi cut up into 7 equal pieces, and then stick an x in here. So this would then generate this. We've done this before, so I'm expecting you to know this. So we're going to use the same technique here. If we want the formula for this function, well, we know the amplitude would be c, so it's going to be in a way f of x equals the sine something, and we know it's going to be c here, just like up here. it's going to be c down here. And then to get the period, we would get the whole length here, which is 2 pi, and then we're going to cut out, we're going to, just like here, we would cut it up into 7 equal pieces. Just like down here, we would cut it up into this many pieces. So that would be 2 pi root L over G, and then we're going to stick an X or a T or whatever here. Okay, so this would then become one. Hang on, I'm going to change this to D. So later on we can put D into our machine, and if you look at this, 2 pi cancel out with this 2 pi here, so it would be 1 over root L over G, and then stick a D in here. So now this thing here will generate this. Okay, so now I need to show you how to simplify. Oops, hang on. Now I need to show you how to simplify this. So bear with me. So let's try and simplify this, because at the moment it looks ugly. 1 over root L over G. G is 10, so we can hard code this and put a 10 in there. Let's just say this whole thing here equals x. Our job later on is to get x on its own. Just bear that in mind. So now we're going to take the reciprocal of both sides. So that will then, so imagine this as one thing over another thing. So that would be root L over 10. Take the reciprocal of the right hand side. That would be 1 over x. And then square both sides. That would be L over 10 equals 1 over x squared. Take the reciprocal of both sides. That would be 10 over L equals x squared. Take the square root of both sides. That will then give us this. So x turns out to be, so this complicated thing here turns out to be 10 root 10 over L. So rather than having 1 over root whatever here, you can just turn this whole thing into this. So overall, it would be this. Bear with me. Overall, it would be c sine, and then root 10 over L, and then stick a D in here. So this will then create our function earlier. So by punching this into Desmos, we are going to create this function where it will oscillate between C and negative C, and the time it takes to do one oscillation would be 2 pi root L over G. Okay, so we now need to punch this into Desmos. So I will continue in the next video.